Good morning, student. Today we will discuss the experimental part of surface chemistry, and this is very useful for the MSc first semester chemistry, physical chemistry student. As you know that you have to perform large number of experiment during your course, and one of the most important experiment is determination of critical micelle concentration of a surfactant by surface tension measurement. So what I have planned, I have divided today's presentation into two parts. In first part, because whenever you perform any experiment, you must know the theory, proper explanation of this chemistry involved in that experiment. So in first part, very briefly I will discuss the theoretical part of that surface tension measurement, and in second part I will perform one or two experiments with the help of my research scholar. So let me start the part first. Now you know that there are many methods available for the determination of CMC. In most of the MSc classes, we do measure observed conductance, or sometimes we measure the surface tension. Here we will measure the surface tension by Du-Nouy ring method. Fortunately, our department having very sophisticated tensiometer. I will explain gradually. So we will perform this experiment with that tensiometer. Now why this experiment is important? Because there are two parts. First part is the determination of critical micelle concentrations. And you know that there are large number of surfactants, cationic, anionic, non-ionic, deuterionic, even some Gemini surfactants. So here I will give you most common surfactant which is easily available everywhere, and that is cetyl trimethyl ammonium bromide, CTAB, which is a cationic surfactant. And I will give sodium dodecyl sulfate to other student. So that is a anionic surfactant. So that is the experiment number 1. Today I will not discuss the experimental number 2. With the help of these CMC values or with the help of this surface tension, you can also perform another very important experiment to study the Gibbs adsorption isotherm. And our students do this experiment without any problem. And here we will also determine two important surface properties, that is called the surface excess and minimum surface area. But don't worry, today I will concentrate only on the first experiment, that is the critical micelle concentration. Now, before I start the discussion, what is critical micelle concentration? When you will promote to the second semester, you will study details in the surface chemistry, but it is a characteristic properties of the surfactant. And you know that surfactant is just like there is a head group which is hydrophilic in nature, and there is a tail group that is hydrophobic in nature, and head group may be cationic, and there is a counter ion is also there. So, and most of the surfactants, I am not saying that all surfactants are not liquids, but CTAB or sodium dodecyl sulfates are solid substances, very nice crystalline substances. Now, when we dissolve this substance in the water, a particular concentration, that monomer or that surfactant forms the micelle. Micelle formations. So that is the concentration where that surfactant form the micelle is called critical micelle concentration. That is the definition of the critical micelle concentration. And it is surfactant, that means it is a surface active reagents. If you study the surfactant chemistry, it has a tremendous properties and it has got tremendous application in chemistry, but it generally decreases the surface tension of the water. So basically for MSc student we will do the CTAB, and second is the, when you perform the experiment, I will repeat something, and for clarity and novelty I am just telling you that, but you have to determine the approximate, the CMC of CTAB is 1 millimole, you can see it now, 1 millimole, and so SDS is 8 millimole, and it depends upon the solvent, temperature and other things. Now methods. Please see it very carefully, because sometimes if you don't have any sophisticated equipment, so you have to use the very common instrument, a glassware, which is called the stalagmometer. And I think during your BSc classes, you have already studied the principle of that drop weight method. So it is the most simple method, and most of the colleges and schools, they are using that stalagmometer. It is moderate and simple for BSc students. There is no problem. You can determine the surface tension of various mixtures. You can determine the surface tension of the surfactants. But it is a drop weight method, and for that you have to calculate the density, because it weight or mass of that drop. Second method is called tensiometric method. Sometimes you can directly determine the surface tension, and fortunately we are having a very sophisticated, very costly Du-Nouy tensiometer, Kayo group, and is a well established and more utilized method and accurate. You will get the accurate value. So, and I am really grateful to the DST FIST, Government of India. So, we purchased this instrument. So I am grateful to Department of Science and Technology FIST. And another Wilhelm plate method is also there, and it is also very accurate. You can calculate, but today I will discuss the Du-Nouy tensiometer method. And the difference is that generally here we will take one platinum ring, whereas if it is a Wilhelm plate, so we will take a platinum plate like that. This is the difference. And in addition to that, in some laboratory they use the capillary rise method or bubble pressure method, good for dynamic type of, but it's less preferred. So today we'll use that. And in addition to that, in our lab we are having some Indian made tensiometer. We'll also try for that. Now, so you saw the picture of all those methods. So it is the actually Kayo group tensiometer, and it is computer operated. Of course, in our system there is a desktop method, and it is the GenCon type of instrument, and it is available in our country also. And there are two systems, one is automatic, another is the manual. And you know, it is a very simple stalgometer method where we can take some surfactant solution and just count the drops, particularly say capillary. And if you see my lab, so today we'll use this. When you perform the experiment, you are all MSc first semester students, and every year they perform this experiment, nothing new. But for the clarity and novelty, I am just using, before doing the experiment, now it is necessary to learn the technique, some theory and the background like that. So this is, you so see that this is our actually tensiometer, Kayo. And here actually there is a platinum ring. I will show you that platinum ring. And we'll take a beaker and gradually we just touch that place. I'll see the technique. And automatically that computer this monitor the surface tension. You need not to be worried about the force acting on that surface. And that is the another type of things. It is a manually operated surface tensiometer, GenCon. And I have purchased it from, I think, UGC, one from UGC grant. And another is the same model, but it's an automatic model. I have purchased from the CSIR project grant. And it is DST, FIST. So here we can take that beaker and the ring is there. Like that, and you can measure. Now you see the difference between that is the old model. So the unit is dyne per centimeter, but there we take the Newton per meter SI unit. And in addition to that, this is the actually picnometer for determination of the density. And there are different types of models are available in the market. Simple glassware you see like that. So yes, you have to determine the surface tension with the help of these three instruments. One very sophisticated, then indigenous, and this very simple method. And then you have to compare, because sometimes CMC is dependent on the methods also, although there is not much difference, but that is the things. Now first I will explain what is the difference between the Wilhelm plate method, because this is the very old method. And the great scientist, German scientist, Ludwig Wilhelm, 1863, he actually discovered this method. And you know that here we will use a thin platinum plate is vertically immersed into the liquid. And downward force due to the surface tension is measured when the plate contacts the liquid. And this force is proportional to the perimeter of the plate. A vertically suspended plate touches the liquid surface. You know that if I take a surface and a liquid droplet is here, so there is no problem. But you know here there is upward pull, see the there is maybe a contraction like that. And this is actually surface tension and force acting per unit length. So here is also Newton per meter, measured force, and directly you can measure the surface tension. P is the weighted perimeter of the plate, contact angle, generally theta or cos theta. This can. I've taken this photograph from the Wikipedia, these photographs of this. I will not discuss the details of the theory because our objective is to perform the experiment, and before doing the experiment, you must know some of the fundamentals. Now, yes, now we are now using, or the student will use this Du-Nouy ring method. And again, this was discovered by this great scientist, French scientist, Pierre Lecomte Du-Nouy in 1925. There are large papers are also available. So in place of plate, here we'll use a ring. I'll show you that ring photographs. And the theory is almost same, that the platinum ring is submerged below the liquid surface, and there is a, there is inward pull, and one force is acting just when the inward pull and upward pull. Of course, this all depends on the cohesive force. So just is detach, वहाँ से निकल आएगा. और वो जो force है, that is the surface tension. That is the surface tension. And there are some correction parameters is also there. The radius of the ring is also very important. But fortunately, because we are using automatic टेंसियोमीटर, तो आपको फोर्स की करने की ज़रूरत नहीं है. आपको केवल सॉल्यूशंस को अच्छे से बनाना है और उस सॉल्यूशंस को बिल्कुल हर अलग अलग सॉल्यूशन को रखना. मैं बताऊंगा मेथड कैसे करना है. और जहाँ पे वो डिअटैच हो जा रहा है, एंड दैट इज द डायरेक्ट सरफेस टेंशन, लाइक दैट. नाउ द क्वेश्चन इज दैट surface tension, what is actually surface tension? And the force required to detach the ring. You see that this is the suppose surface of the liquid, because here actually that particular molecule experience a contractions, and suppose this is the ring. Just touch it here. So we generally call it like a particular length. So the force required to detach just from the liquid surface can be related to the surface tension, and that force is directly related to the surface tension of the liquid. And if I ask you that, can you explain the surface tension? So you can. That surface tension is the force per unit length in meter of force that acts along the surface of the liquid. And this force always acts at right angle to the line and along the surface of the liquid. Now bear in mind, कभी कभी स्टूडेंट का कंफ्यूजन हो जाता है. The force is measured in Newton per meter. ये ऐसा यूनिट की मैं बात कर रहा हूँ. बट अगर आप पुराना रेफरेंस देखेंगे, ओल्ड बुक्स देखेंगे, तो ऑफ कोर्स यू कैन कैलकुलेट इन द डाइन्स पर सेंटीमीटर. मतलब हाउ मच फोर्स इज एक्टिंग अलोंग ईच मीटर ऑफ द लाइन, एंड दैट इज यू कैन कन्वर्ट इट लाइक वन डाइन. बहुत छोटा सा यूनिट है. सो 1 न्यूटन पर मीटर इज 1000 डाइन पर सेंटीमीटर. So 1 dyne per centimeter is 0.001 Newton per meter. But here actually we will use millinewton. आपके जो कंप्यूटर में डायरेक्ट वैल्यू आएंगे, डोंट वरी अबाउट द यूनिट. इट इज नॉट न्यूटन पर मीटर, बिकॉज 1 न्यूटन मीटर इज इक्वल टू 1000 मिली न्यूटन पर मीटर. ये बहुत छोटा यूनिट है, तो इसलिए आपको जो डायरेक्ट वैल्यूज आएगा, डोंट वरी फॉर दैट. You have to write whatever 75 or 72 or 36 or 50.1, whatever you are getting directly. That computer will, we have a software, so directly will get the values of surface tension in meter, millinewton per meter, because it is caused because the molecules on the surface of a liquid are pulled inward by the molecules below them. This pulling create tension of the, मतलब वो मिनिमम जगह को घेरने की कोशिश करेगा. जैसा आप देख रहे हैं। अब मैं एक्सपेरिमेंट को कैसे करेंगे, सबसे पहले you prepare different solutions, and you know that the platinum ring is very important, so you have to clean that platinum ring. So there are two methods: either you wash it with the methyl alcohol or it must be heated with a flame. उसके बाद the platinum ring is gently lowered until it touches the, बिल्कुल आपको धीरे धीरे ऑटोमेटिकली उसको वहाँ पे टच कराना है. And the maximum force required to detach, I think it will take only less than 1 minute. So it is a so simple method. Now what materials is required today? मैंने आपको दो surfactant देंगे. One is cetyl trimethyl ammonium bromide. You see, this is the tail, this is trimethyl ammonium is the head, and bromide is the counter end. ये कैटायनिक देंगे, और एक हम देंगे आपको सोडियम डोडेसाइल सल्फेट SDS, इज एनायनिक सर्फेक्टेंट्स. आप जब एक्सपेरिमेंट करेंगे तो आपको मैं सारी चीज़ को दिखाऊंगा. वी नीड डिस्टिल वाटर, वॉल्यूमेट्रिक फ्लास्क, टेंसियोमीटर, प्लेटिनम रिंग, माइक्रोपिपेट, थर्मोमीटर्स, एक्सेट्रा. फर्स्ट यू प्रिपेयर, एंड यू हैव ऑलरेडी प्रिपेयर्ड, क्योंकि मैं कल से आपको बताया हूँ, यू हैव ऑलरेडी प्रिपेयर्ड डिफरेंट सोल्यूशन ऑफ sodium dodecyl sulfate. The rules is that, as you know, that the CMC of CTAB is 1 millimole. तो आपको जो सोल्यूशन बनाना है, 4-5 सोल्यूशन लेस देन 1 millimole, एंड कुछ सोल्यूशन आपको उसके आगे आपको बनाना है. दैट मीन्स देयर आर टू रीजन, वन इज प्री मिसलर रीजन, अनदर इज द पोस्ट मिसलर रीजन. यूज ऑलवेज डिस्टिल वाटर, देन कैलिब्रेट योर टेंसियोमीटर. अभी आप करेंगे, इसको ज़्यादा बोलने की ज़रूरत नहीं है. प्लेटिनम रिंग को क्लीन करेंगे, उसको फ्लेम में हीटिंग करेंगे. देन वंस योर, समटाइम बैलेंस करना भी ज़रूरत है, वहाँ पे स्पिरिट लेवल रखा हुआ है. सो एवरीथिंग इज रेडी. नाउ फर्स्ट you determine the surface tension of water. Sometimes they supply a special type of the water and you measure the surface tension. If it is exactly match with that standard value, then your tensiometer is all right. Then measure directly the surface tension. अभी आपको फोटोग्राफ्स में जब सेकेंड पार्ट में आप देखेंगे तो आपको पूरा दिखेगा कि कैसे आप उसको मेजर करेंगे. एंड रिपीट दिस फॉर ईच CTAB सोल्यूशन. आप जितने, मान लो सपोज यू हैव प्रिपेयर्ड 7 सोल्यूशन, तो 7 बार आप उसका सरफेस टेंशन निकालिए. क्लीन द प्लेटिनम रिंग. हर बार आफ्टर ईच एक्सपेरिमेंट यू हैव टू क्लीन दैट टेंसियोमीटर. एंड अल्टीमेटली लास्ट में व्हेन यू सपोज, अभी हम फोटोग्राफ्स में दिखाएंगे, सपोज देयर आर 5 सोल्यूशंस एंड यू प्लॉट the surface tension and concentration, whatever. I am just talking about the surface tension method, not conductance method. So कहीं भी मान लो ऐसा आया, so there must be some break point. That break point is that CMC, and also monitor the temperature also. So I am giving some old data. आज के डेटा तो आज आप देखेंगे. ये मेरे MSc के स्टूडेंट्स with the help of the research scholars, they have determined the CMC of cetyl trimethyl ammonium bromide. You see, there are different types of solutions of CTAB, and it is millinewton surface tension. There are some values, and the computer will directly draw the plot. आपको कुछ नहीं करना है, and you see that there is a decrease in surface tension. And because you know that, मान लीजिए ये आपका वाटर है, तो ये because it is in hydrophobic in nature, as you increase the concentration, so the whole surface is covered by that surfactants, and ultimately it will also break the water structure also. So therefore the decrease, and एक समय आएगा जब ये whole cover is, and they will prepare a micelles. So let me summarize that my objective is that today you have to perform the experiment CMC by the surface tension method using a very sophisticated equipment, Du-Nouy Make tensiometer. For that, in this first part, I discuss some very fundamental aspects of the surface tension. What is the difference between the plate method and ring method, and how you perform the experiment. Now please now come to the lab for the experimental part. That will be the part 2. Thank you very much.